So atomic memory operations have a number of limitations that you need to know about. First of all, only certain operations and data types are supported. Okay, so there's things like add and subtract and min and XOR and so forth, but you can't do every operation. There's no mod, for example. There's no exponentiate. You can't do every operation, and only certain data types are supported. In particular, mostly integer types. So atomic add and atomic exchange are the only types that actually support floating point operations. There's a workaround for this. It turns out that you can implement any atomic operation by using the atomic compare and swap operation. And I'm not going to go into the details. This gets into mutexes and critical sections. There's a short example in the programming guide that gives you an example of how to implement, for example, 64-bit operations using atomic CAS. You need to be aware that there's still no ordering constraints, right? So the different threads in a thread block and the different thread blocks themselves will be running in some unspecified order. It'll be different every time. And so the operations that you're performing on memory using atomics are still going to happen in an unspecified order. This is important because floating point arithmetic is actually non-associative. In other words, the quantity of a plus b plus c is not the same as a plus the quantity of b plus c. It's real easy to convince yourself if you look at numbers like, say, a equal 1, b equal 10 to the 99th, and c equal negative 10 to the 99th. You can just plug this into your C compiler and or your calculator for that matter, and you'll discover that you don't get the same number depending on what order you do these operations in. And the final thing to be really aware of with atomics is that there's no magic happening under the hood. The GPU is still forcing each thread to take turns getting access to that memory. It's serializing the access to memory among the different threads. And this can make atomic operations very slow if you're not careful. Let's look into that.